All right, let's look at error, relative error, and percentage error. All right. So if let's say you're measuring something, the length or volume or whatever. If you measure something, and of course, if you're doing it manually, there's going to be always an error. All right. Then let's say you measure the one side of a cube, and you're going to have certain error, and you want to see how much of that error corresponds to the error in computing the volume of the cube or something like that. All right, and but depending on how big the object is, so if you're looking at a really tiny cube and you have 1 millimeter of error, and it's going to be a gigantic error with respect to a tiny cube. But if you have a 1 millimeter of air, you're measuring one side of a cube, and they're talking about a gigantic cube. It's not going to make much of a difference. So we want to look at something called the relative error, so that with respect to the size of the thing and how big the error is. All right, so that's called relative error, and if you turn that into a percentage, it's called a percentage error. So they're essentially the same thing. All right, so here's how it goes. So you have error. Let's say you have you're trying to find the value of f of x, and measuring the x value, you're going to have a certain error called delta x. And what kind of error do we get in y value? All right. So what we want to do, so this is going to be an error in computing, calculating y value, right? So that's going to be delta y, right? And then what we want to do is we want to approximate it. So error in delta y, so this delta y is an error. So we're going to approximate it using dy, right? Which is f prime of whatever the a is. Maybe I'll just use x, and then dx, right? And this will give you the error in calculating y value, right? But relative error, it just you divide this error by the size of y. So this is called the relative error, right? Which is delta y over with respect to the size of y, right? Which can be approximated by dy over y, right? And a percentage error is simply multiply relative error, because that's going to be a ratio, right? And then you just multiply by 100. So turning into percentage, right? So this can be approximated by dy over y times 100. All right. All right, let's look at a simple example. Here, again, we have a cube. Let's say we measure it. It's a 2 feet by 2 feet by 2 feet cube, but there might be an error. Error is about 0.1 feet in measuring one side. All right, volume is, actually I messed up. The volume is v is equal to x cubed, right? So if you want to find error in volume, so that's going to be delta v, right? And we want to approximate it by differential dv, right? Which is going to be derivative v times dx. Right, so we're going to set the dx equal to delta x, so dx is going to be 0.1, and we need to find a derivative. Oops. So derivative of v is going to be just a 3x squared, just a power rule, right? So if you find that, so this is going to be here, I have v prime of, so x is 2, and the delta x is 0.1, so times 0.1, and v prime of 2 is 3 times 2 squared times 0.1, right? So what's that? So this is going to be 2 times 2 is 4, times 3 is 12. 12 times 0.1 is going to be 1.2, right? So 1.2 cubic feet is the air, right? And if you want to find the relative air, right, which is delta V over V, right? And this is going to be equal to, or not equal to, we can approximate it by dV over V, right? So we have dV already found, so we're going to put the 1.2. And the volume is going to be, let's see, so it's a 2 by 2 by 2, so volume is 2 cubed, right? So this is going to be 8. Is that okay? So let's simplify. Let's see. Divide by 4, so it's going to be 0.3 by 4, so it's 2. Actually, you can. So it's going to be 0.15, right? So this is the relative error, right? And then if you want to find the percentage error, not much work is required. So we're trying to find the delta V over V times 100 so that it becomes a percentage, but we're approximating by dV over V by 100, and which is, we already found dV of relative error, which is 0.15, and multiply by 100, which comes out to be 15%. Right, so the relative error in calculating volume is 15%. Right, that's it. I hope that this was clear.